In chapter 7, we learned a lot about different transformations. In this section 8.7, we're going to learn about a dilation, which is a type of transformation, but it's what we call a non-rigid transformation. It's a transformation where the pre-image and image are not congruent, or isometries, if you remember chapter 7's vocabulary. So, in a dilation, you're basically taking a shape and you are going to be enlarging it or shrinking it from a center of dilation. So, um, oftentimes you can think about, like, if this was a light source and you put something in front of it, the shadow would be kind of a form of a dilation. Or, dilation, something you talk about your eyes dilating, the pupils getting bigger and smaller. So the scale factor, which we call K, from the center of dilation to P prime, remember P prime is the image, and P is the pre-image. So the pre-image goes on bottom. And this will make sense because if we're having if K is an enlargement, we want K to be greater than 1. And if it's a reduction, we want K to be less than 1. So if this number is smaller than the bottom, that means it shrank. Okay, so in a rigid transformation, the pre-image and image are congruent, or isometries. In a dilation, the perimeter and image are not congruent because this is a dilation. It's non-rigid. So this is what we say similar. And that's why it fits in with this section. So identify the dilation and find its scale factor. So they're asking, is this a enlargement or a reduction? And so in this case, here is my final image, right? And this was my pre-image. So just looking at it, hopefully you see this is A is an enlargement. Okay, so it's an enlargement, and find the scale factor. We want to know what K is. So from the center of dilation to A is a length of 3, and that goes on the bottom. From center dilation to A prime is 7. So this was a scale factor of 7/3, which is greater than 1, so that makes sense. This one's a little tricky, and you'll have some that are tricky like this. Here's my pre-image. Here's my image. The image got smaller, so it's a reduction. And some people get this wrong because they'll say from C to Q prime is 3, and then here's 1, and they'll write a 1 here, but it's from C to Q, from center dilation to Q. That's a length of 4. So the scale factor on this one is 4. So make sure when you're doing these problems in this chapter that you keep straight. That sometimes you want to add numbers together or subtract numbers. In this next one, with a coordinate plane, when you use a scale factor of 3/2, what you can do is you can multiply your point by the scale factor. So in this case, A prime, I'm going to multiply these points by 3/2. So -2 times 3/2 is a -3. 1 times the 3 halves is 1.5. So that's where A prime is going. B prime is going to go to negative 6 times 3 halves is 9. Negative 9. And 0 times that is still 0. C prime is going to be negative 1.5, negative 1.5. I'm multiplying these coordinates by 3 halves. And now I can plot how does the perimeter of the image compare to the perimeter of the pre-image. Well, I'm going to give you a clue. Remember the dilations. I'm going to plot these points. Can't. That's A prime, negative 9, 0, B prime, negative 1.5, negative 1.5 is going to be down here. So there's the after the dilation. You can plot these two, negative 2, 1, negative 6, 0, and negative 1, negative 1. This was the original pre-image. And notice we were dilating it about the origin. And if I were to draw some lines through these, notice these points all line up with that center of dilation. Now, one of the things we talked about before is this triangle is going to be similar to this triangle. And we talked about this in a different chapter, is the ratio of the perimeters is also going to be the same. And the ratio of the scale factor of the dilation is going to be the same as the scale factor of the sides. So the ratio of the perimeters is also going to be 3 to 2. Okay, because of the similar triangles. There's your homework.